Hello, and today we're going to be looking at the ellipse locus once again, but this time we're going to be using something called the eccentricity, spelt like so. So the eccentricity is just some number. Um, for this video, we'll be focusing at when this number is less than 1. Um, And normally we say that eccentricity is little e, so keep that in mind. So with that, I'm going to set up some things. So our locus point is going to be x comma y, and I'm going to define a focus, which is a, e, comma, 0, and a is just a general number, e is the eccentricity, and then m, which is a over e, comma y. So where does this fall on our graph? So here's a rough sketch of our graph, and let's say this right here, that's our focus there. And this m here is going to be what's called a directrix, a straight line in some direction. In this case, it's going to be x equals a over e, and this straight line here is going to be all possible points of m. So with that in mind, our condition is p to f is equal to some eccentricity p to m. So what that means, so if my eccentricity is 1/2, if I go up that far, I need to make sure that this distance here is double. And what this will form is this sort of strange elliptical kind of shape. But it will only form half. So the catch is that the focus and the directrix are actually plus minus AE and plus minus A over E. So there's actually a second half that'll form the rest and a second directrix there. And with that, a second focus. Alright, so let's do some general stuff. So P to F is equal to the eccentricity times P to M. Let's write the distance formula for it. So first, P to F is going to be x minus A times E squared plus y minus 0 squared. It's going to equal E times the square root of x minus A over E squared plus y minus y squared. Remembering the points for the focus and the directrix. I'm now going to square both sides and simplify a little bit. So x minus AE squared plus y squared is going to equal E squared, lots of x minus A over E squared. Now, you don't have to put double brackets here, but just to distinguish it, you can. So now we're going to expand both sides. So this will become x squared minus 2aex plus a squared e squared, remembering that a plus b squared is always going to equal a squared plus 2ab plus b squared. With that in mind, apply the same logic here. Plus y squared equals e squared. I'm not going to expand it in just yet. X squared minus 2ax over e plus a squared over e squared Now I'm going to expand e inwards. So we'll have e squared x squared minus 2aex plus a squared. You can now have some cancelling. This minus 2ax can cancel on both sides. I'm now going to shift everything with an x onto this side and everything with an a onto this side. So I will get x squared minus e squared x squared plus y squared. It's going to equal a squared minus a squared e squared. I'm now going to factor out the x squareds here and the a squareds here. So we'll get x squared lots of 1 minus e squared plus y squared is going to equal a squared lots of 1 minus e squared. So because I'm running out of space, I'm going to rewrite it, and you will appear like nothing has actually happened. Now divide everything by a squared lots of 1 minus e squared. So we get x squared lots of 1 minus e squared plus y squared equals 1. Divide this by a squared lots of 1 minus e squared, and over a squared lots of 1 minus e squared. We have some cancelling here and here, so we are left with x squared over a squared plus y squared over a squared lots of 1 minus e squared, which equals 1. And now we can put this into our general form. X squared over a squared plus y squared over b squared is 1, where b squared equals a squared lots of 1 minus e squared. With this, we can actually draw an ellipse. So long as we have two focuses and two directrices, remembering the plus minus. So let's do an example question. X squared plus y squared over 25 over 4 equals 1. So a is going to equal 5 and b is going to equal 2. So if b squared equals a squared lots of 1 minus e squared, 4 is going to equal 25 lots of 1 minus e squared. Divide by 25, 4 over 25 equals 1 minus e squared. We can swap e squared with 4 over 25, just to get e squared as the subject. So e squared equals 1 minus 4 over 25, which equals 25 minus 4 over 25, which equals 21 over 25. So e is going to equal the square root of 21 over 25, which equals square root of 21 over 5. Now that we have our eccentricity, we can work out what the focus is. Our focus is going to be plus minus ae, comma 0, a times e. So if e is root 21 over 5 and a is 5, we're going to be left with root 21, comma 0. And to help us graph it, we're going to put a approximate value, so you can just plug in root 21 and work out that it's around about 4.6. The directrix is going to equal x equals, what we can do to make this nicer, because e is a fraction, is say that x is equal to a times the reciprocal of e, or e to the power of minus 1. So x will equal a times 5 over root 21. A is 5, so we're left with 25 over root 21. and we can find out that this is approximately 5.5. So this is what the locus will look like when graphed. The blue is the P points, F is the focus, and these black lines here are the directrices. And you can see that it forms a ellipse. You can see that it is 2 up and down and 5 across from the center. And you can play around with this as much as you want. You can change the A value. You can set it to 2. Find out, oh look, it's a circle. Wonder why that is. Hey look, the focuses are all converged into one thing. Why is that? We can also change our B value. And also change the position of our locus by dragging the center or changing the H and K values. These work the exact same way as a circle's position works, as you can see in the equation up here. And we can read off what the E value is approximately to. Now this E value is capital because Desmos doesn't like using the lowercase e. The lowercase e is Euler's number, which is around about 2.7, and that's a very particular number. It's sort of like pi, but you can see the equation, you can play around with the sliders, and you can also take a look at how I got all of these lines in place perfectly. And all of this is in the description down below, so you can go check it out yourselves. So that's all the time that I have for today on locuses. If you have any questions, feel free to leave a comment down below or contact me on social media, and I will see you in the next video.